All right. Howdy, y'all.
Hey everyone. Hello, Twitchland. Everybody out there. Howdy.
Hey,
Welcome
how
to
you guys doing?
another episode of Howdy Partner.
Awesome, awesome. Well, thank you, everyone. This is my first time doing a howdy partner as far as with you, David. So I'm very excited for our wonderful show today. We have a really cool partner coming up today. And if you are all new to this, Howdy Partner is a weekly live streaming series where we highlight AWS Partner and the APN, which is our AWS Partner Network, where they, tell us their journey as far as them being an APN, what new and amazing solutions that they have to deliver to partners and customers, and just a nice lay your hair down session where we can learn about the amazing things that our partners are doing and building with us. So, are you excited, David?
Yeah, absolutely. I think you nailed it there, Patrick. How you doing, by the way?
I'm doing great. It's one of those months. We just got sales kickoff, so I know a lot of companies are ramping up as far as to their strategy. So yeah, it's been very very fun, and I'm looking forward to the year. So I'm curious about you. How you doing, David?
I'm good. I'm good. I feel like I've been in a deep hibernation for a while. It's March now, but this is my first Howdy Partner episode of the year. So my return to Howdy Partner for now.
Awesome. That's
But
great.
yeah,
Well, let's make it a great one. And I think we have a really great partner for you to, break out the year as far as in fashion. So we do have a partner named Classiq. They have a really amazing solution, and they're all about quantum computing. So maybe many like you watching the show, like me, are not too familiar or at least an expert in this. So we do have a really great partner coming in, and we do have as far as special guest named Erik, and we're gonna go ahead and bring him on the show. How's that sound, David?
sounds awesome. I'm excited. Let's do it.
Awesome, awesome. Let's bring him to the stage.
All righty.
Hello
Howdy.
there.
Hey, Erik.
Howdy, Erik. How you doing?
I'm doing great. I'm actually just finishing wrapping up my day here at the American Physical Society in Minnesota. So it's been a long day, but a good day talking to clients and different people interested in quantum. And it's just fun getting into these cool conversations about all the really interesting stuff people are doing in the quantum space.
How's the weather there in Minnesota today?
It was pretty good. I got worried when I heard some of the sirens go off. Apparently there was a tornado warning. I don't know if it was a test or I don't know. I got confused. I hear sirens going off. I start figuring out where do I need to go.
Hey, everybody in Twitchland out there in the chat, go ahead and throw in the chat where you're watching from today. Go ahead and be interactive, ask some questions, and anything you've got for Erik or Patrick or myself, let us know.
But, any recommendations of where to go in Minnesota? Because my first time here.
I don't know. I actually had to go to Minnesota of April of last year, and I was expecting it to be super cold, but I came back with a sunburn. So,
ooh, all right.
Oh wow,
yeah, lovely weather. I was walking around with a t-shirt, so it was pretty cool.
Oh man, I had a different experience when I went to Minnesota. I went a few years ago. So yeah, it was I believe like 18 degrees. I'm a Miami guy, so I'm not used to that type of weather whatsoever. So it was quite shocking, but I did have a really good time at I went to Paisley Park. So that was really interesting. I'm a big Prince fan, so that was pretty cool.
It's awesome.
I grew up in Miami, Florida, and I moved up actually to Rochester, New York for school. I went from as far south as you can go to as far north almost as you can go in the U.S. And I went from never having had seen snow to blizzards, and that was rough. That was a rough transition.
Yeah, that's tough. Awesome. So I guess before we even get to Classiq, let's just know more about as far as you, Erik. So I guess what got you interested in quantum computing, and what was that? How's that journey been like?
I mean, I've always been interested in quantum in general, right? Even from high school and stuff. Quantum is just an interesting topic, right? Things can be both a particle and a wave, and it kind of it sounds confusing and it's cool, and you know that it's real, but it's hard to grasp the concepts. I just thought it was a really cool and interesting topic. I ended up getting my PhD in physics, in laser physics, actually, not in quantum. I ended up in this field because I found out slowly through kind of getting my physics degree, there are people, brilliant scientists out there who are coming up with technologies that are saving people's lives. They have no idea how to talk about it or make it sound interesting. So while I got my physics degree, I got my business degree there to help articulate kind of why science is cool or interesting and why people should matter. Because, you know, sometimes the most brilliant people in the world, they don't have the skill to translate that and bring that out. You know, they can do the hard work of actually making the tech that will improve our lives and save our lives, but actually making it understandable to somebody else and letting them know the importance of it or why it's cool or interesting. It's a skill I found that was just needed in the industry, and I worked on that and I loved it. And now I'm doing kind of you know, technical marketing for quantum and telling everybody kind of why quantum's cool and interesting and the interesting stuff it can do. And you know, always trying to thread that needle between letting everybody know is, you know, why it's cool, and I'm definitely super emphatic about it, but not overhyping at the same time.
Right. Well, that's great. And you know, many of us, and I guess I may even be able to speak for the viewers. We may not, as far as, know exactly what quantum computing is. So, can you enlighten us as far as a high level overview, like what that is, if you can?
Yeah, quantum computing is a new type of computing that uses quantum physics instead of using bits for a computer that are kind of binary. You know, you turn a bit on, off, 1, 0 kind of thing. You're used to seeing that. You put those through, you know, ands and ors and if statements, and you put enough of those together and you can do some math. You put enough of those together and you can do more interesting things. With quantum computing, instead of using kind of systems that are ones or zeros, you use systems that can be somewhere in between 1 and 0. It's a probability of being 1 and 0. So it can be like, you know, 20% probability that it'll be a 1 and 80% probability it'll be a 0. And with this probability bits, almost, you know, qubits, what we're calling it, quantum bits, you can do some really interesting maths that you wouldn't be able to do otherwise. And some scientists, much more brilliant than I, have found out how to do some really cool algorithms and take this stuff and use it for really interesting applications. Stuff that, you know, okay, qubits, it sounds cool and everything, but we've been able to take that technology and really do some nifty stuff with it.
Wow. That's pretty amazing.
Yeah, for anybody that's tuned into multiple Howdy Partner episodes where we've had quantum computing, I feel like I've done a couple of them, and yeah, it's still it's fascinating. It's really awesome, fascinating stuff. But what little bit I've learned about it, doing a couple episodes and in my own research, it's yeah, I would love to get into it a bit more and kind of become like an expert. Like we do have, you know, our resident quantum expert, Perminder, who usually joins us for these episodes, and he may be joining us today, but he did have a circumstance that he had to deal with. So if we see or hear from him, we'll be happy to bring him on. But yeah, I'm excited to hear more about it.
Yeah, and I'm happy to take this like a Reddit AMA. If you guys have questions about it, ask. Feel free, right? I can talk anywhere from, you know, I love talking shop about the different types of doing quantum computing, right? There's a lot of different ways to make, you know, these quantum computers, the same way there's a lot of different ways to make bits, right? You have bits on your computer that's running things, you know, a CD, and I mean, well, CDs, who's using CDs these days? I don't know. Blu-ray's the closest, but physical media is dying on us, right? If you look close enough, it's just a bunch of grooves and not grooves, and that's your 0 and your 1, and enough of those lined together make the data that is the movie you're watching, right? So there's different ways that you can make probabilistic bits and do that to do some cool computation. You know,
it's funny that you mentioned that. I just got rid of all my CDs, but yeah, I got rid of all my CDs, and now I'm getting into collecting vinyl. So I'm going back in time.
Wow. And it's funny you brought that up, because when I was in Minnesota, I actually visited the studio, the actual record store that Prince used to go to as a child, as a kid. So that is funny that this all correlates. Interesting.
Oh yeah, no, it's interesting stuff. I mean, physical media is dying. I showed my daughter a floppy disk the other day, and she goes, "Oh, it's the save icon." I go, "Oh no, this is a thing." This is okay. We have different history lessons here.
Right. Yeah, we're getting there, man. We're getting there.
The kids will make you feel old.
Oh, and I saw the comment. Thanks for the stash comment. Yeah, I'm a fan. It's good. It helps in my line of work. I go to these conferences. Like I said, I'm at APS, and the American Physical Society meeting. And, I go to these conferences year after year, and someone says, I don't remember your name, but I remember we talked last year because that mustache, I remember it.
Right. That's amazing. I'm curious, like, what's more of a, as far as an icebreaker, talking about quantum or the stash. Yeah. So that's a pretty interesting, call out. So that's awesome. And I guess, as far as like and thank you for telling us as far as your journey, into the quantum realm. As far as Classiq, tell us more about Classiq if you don't mind.
Oh, totally. Right. I mean, that's kind of why we're here. But I like the company, but I'm biased. But I'll tell you all about it anyways. We're a software development platform for quantum computers. We're trying to create kind of an end-to-end platform to make it easier for people to use all the great technology that's being developed. Right. I'm sure you've had hardware developers on this show talk about their cool stuff. I'm at a show that's talking about there's a lot of people out here showing the newest and greatest control circuitry, the newest and greatest, number of qubits, how good they are, things like this. Having all that hardware is great, but you got to be able to program for it. And with the more and more resources you have, it's getting harder and harder to program these things kind of in the way that most people are used to programming them. Kind of the paradigm for programming quantum computers right now is at the assembly level language. Kind of programming at the this Boolean logic and or if kind of statements to put together your program. And I like to tell people, if you have a chance to program a web page, would you rather do that in Boolean logic or would you rather do that in HTML? Right? You're not even going to get to hello world if you're trying to do that with ands and ors and ifs, and just gets too cumbersome to build a program that's going to do anything of value if you're programming at that level. It's good to learn kind of, how quantum computing works by, learning all this, but you're not going to be able to do, a financial calculation. You're not going to be able to do anything, more fancy in math than a couple of additions. And that's not going to bring any of the value that, all the media hype sometimes you hear about, all these promises. You're not going to get there programming at that level. And so Classiq is trying to enable that through kind of this end-to-end platform. But we also have a higher level modeling language that abstracts away from this assembly level. So instead of programming at this kind of telling the hardware exactly what to do at the hardware level, you say, what do you want to do in your quantum algorithm? You can just type out your mathematical expression and it's going to figure out the quantum circuitry for you to get there. You can type out if statements and things like that. That's an if statement is a long way away from doing exact, Boolean logic. So it's some cool stuff what the developers put together and kind of making it easy and more feasible for scientists and people in industry to research this, investigate this, and kind of take advantage of, like I said, all the great hardware coming out. IBM and AWS and everybody, you're coming out with all this great hardware that's year after year on your systems, on your platforms. More qubits, better qubits. All right, let's use them.
Right. Right. Yeah. And I think you made a really good call out, especially when you mentioned as far as like my curiosities. Yeah. You mentioned scientists, right? So is this like specifically like for scientists, or can anyone get started? Is this, because you did say it takes away the abstract, and the abstracts like the underlying components, right? Can someone like me get into your platform and use it, or is it, you do have to have some type of certain like knowledge base or anything like that? So I guess is it beginner friendly? To say
it's pretty beginner friendly, right? It's important to still know kind of if you try and get deeper than some simple math, you still need to know what some of these kind of quantum algorithms are and when you'd want to use it, right? So like if you've taken or kind of heard about quantum, I'm sure you heard things like Shor's algorithm or Grover's algorithm, things like that. You need to know what does Grover's algorithm do and when would you want to use that to get to what you're trying to do. But you don't have to know exactly how do I tell the hardware how to do a Grover's algorithm. You just need to know that I need to use this algorithm and go ahead and call that function out. As far as using the software, right, it's free for non-commercial use. As long as you're not trying to make money off of it, you can use it for free, right? So I'm actually at American Physical Society trying to get people to sign up for the platform, students and professors to do research, write academic papers on it. And if you are in industry, it's a standard SaaS platform, right? Software as a service. You buy a license of it, you can use it. We'll onboard you. We're very teach a person to fish, right? Some platforms and companies will do, they'll build a quantum algorithm for you, or they'll show you how to do it, and that's the end of the thing. We want to give you a system and platform for you to investigate this yourselves, right? I'm sure you've heard people talk about, quantum supremacy or quantum utility or things like that. Actually, I'm glad media stopped talking about supremacy. I'm glad we stopped using that word. Quantum utility is what matters, right? When does it start making sense for your business to use quantum over classical? And we want our clients to be the first ones out there to say, hey, Rolls-Royce that we're working with, or and one of these other companies, Citibank, we want them to say, we're the first ones to have quantum utility, because that's what matters, right? Quantum utility only matters so much as it matters to the business.
Right.
So it's much more powerful if we have one of our users come out there and say, hey, I used this platform, and with that, now I have achieved quantum utility, and are the first ones, and they could release that really cool PR piece.
Yeah.
So,
That's
Erik, if I'm like, let's say I'm a business that I don't know anything about quantum, never used it, never thought about it.
Mm-hmm.
What would I benefit from getting into that space? And I guess follow up on that would be like, are you guys like industry agnostic? Are there certain industries that you target more, or is this open for anyone and everyone?
Yeah, well, this is open for anyone and everyone, first and foremost, right? Quantum does have applications for almost every industry, because there's certain classes of problems that quantum computers are going to be really good at, like optimization. There's some applications of machine learning people are looking into. And certainly my developers have swayed me and convinced me that any problem can be mapped out to an optimization problem if you think hard enough about it. But optimization isn't everything. I've had somebody talk to me, one of the last shows I went to, on how they're trying to, play around with quantum algorithms to optimize their whiskey barrel placement. Because that's an optimization problem. How high up do you put your barrel? Because there's a gradient of temperatures in that room. How far back do you put your whiskey barrel in the stack? Because I won't need to rotate that out for so long, but I need to rotate this one out sooner. Okay, that is an optimization problem. But where the industry you're in is really going to depend on when it's going to matter for you, right? There's certain applications in quantum people see as being some of the more near-term applications, like hybrid algorithms. Things like optimization uses an algorithm called QAOA. A lot of people are looking into this for hybrid quantum and classical computation, to use the power of classical computing, but really use the quantum for hone in the quantum to do specific parts of the problem that'll bring the advantage. Let the classical computer do everything else. So we're looking into a lot of things like that right now for the near-term applications. And some industries that are looking into that are, of course, finance, because if a finance company can say, even if they got a fraction of a percent better solution than the classical one, that matters for finance. That might not matter for every industry, a fraction of a percent. They'd want to see more of an improvement. But, finance company can get this fractional benefit and then tell their clients that, through our portfolio optimization that's quantum optimized, you can get that benefit. Ooh, that's nice. All these banks and financial institutes, they're vying over fractions over each other. What's a little bit better than the other. So that's a huge competitive advantage if they can get that. So yeah, like I said, it's a long-winded way to say it depends on your industry, how sensitive you are to, small advantages. So it depends. Some industries won't need a matter for it, for like 10 years. Some might see some really cool applications in the next, 3 to 5.
Wow. So I love the way you said it's not a matter of if, it's literally a matter of when. So
yeah. We've gotten past the science of it. We know the science works. We know that this is happening. We know even mathematically, right, certain algorithms are going to be faster than classical. We just got to get to the point where the whole kind of software to hardware stack, maps out and completes that promise.
Right. Let's take a step back to what you were talking about earlier. We have a question in the chat from Nat Your Yogurt. Awesome name. Do you have a discrete example that you can maybe showcase a comparison other than HTML if else?
Yeah. You know what? Let me go into the platform. I'll just show you some stuff. Why not? Right? Proof's in
Awesome.
the pudding always. I always like live demos as long as the hotel Wi-Fi is cooperating with me. Yeah.
All
So
right, awesome.
and like I said, right, anybody can follow along, make an account if you want. This is platform.classiq.io. I'm logged in already, but there will be a sign up button if you want to do this. There's a bunch of kind of pre done code snippets if you're interested in any of these kinds of problems. HHL, we have some clients doing that for like computational fluid dynamics. Like Rolls-Royce is working with us on that for their avionics division. Some quantum machine learning stuff, chemistry, Grove research. But let's go into the model here. And I was playing around with this one earlier, just showing, kind of the simplicity of the language and how we kind of defining these quantum algorithms. So I'm adding up an equation A plus 2 times B plus C. And A here is a probability state of some qubits. So I have them in some probabilities with essentially just 2 of the qubits have 50% probability, and my variable B has the other 2 qubits and 50% probability. And then my variable C is just the number 5, which oddly enough is not a trivial thing to do if you're doing things at the gate level, to just call out an integer. But here, I'm mixing together both the quantum and some classical math, adding it together and calling out the results here, right? This equation. And this is some simple, coding I'm doing here, but coding out that same amount, if you were doing that in kind of Qiskit or Q# or any of these other kind of languages, would be quite a bit. And this is a 10 qubit quantum circuit I just made in a couple of seconds. You're seeing here that went live to our servers, got returned back. We have our prepared states, our maths here, and you can see how the system added it all up together for us. You can open up all these blocks. Here's our adder. Some quantum Fourier transforms are what make up this. You can see what gates are fundamental, and you can open this up all the way to the individual bits too, and kind of see all of it. You can even download the CHASM file if you want and see what that code would look like if you're trying to do that all yourself. Let's do that. How many lines of code would that have been in CHASM? But like 170 something. If you're doing that in assembly level language, right? And this is the coding you would have to do, right? HCP. You'd have to know exactly how to manipulate the quantum hardware to achieve what you're trying to do. And there's a lot of people who know this stuff, and it's great, but that's a lot of very specific knowledge you have to have in quantum computing. In that hardware, you'd have to know if you're changing hardware to even one AWS machine to another, they have different gate sets, they have different native operations, and you'd have to figure out, how do I change my code to do the exact same thing otherwise? Here you can just export it out to any of them and it's going to work for you.
Wow.
Hey, Erik, so
Yeah.
I don't know if we can have anything cloud related without mentioning generative AI, but is that helping you guys at all? How are you guys using generative AI? Are you able to use that for your code or anything to help you out with that?
It's something I know the developers are taking a look at, but right now we're not doing anything AI based for our coding. It's all hard coded in. So like the way we get you these circuits, right, and this efficient code is through constraint satisfaction problem solving. Right. When I go with my code, let me go into this kind of pre-made code snippet section, because it'll update the code for you here, but it gives you some good examples of what you can do. I can optimize for like the width of my circuit or the depth of my circuit. I can tell it that I want to run on, an Amazon bracket, maybe one of the IonQ machines or something like that. And it knows, right, the native gate set, the hardware, and it looks through a constraint satisfaction problem, trying to solve what you're trying to do in the coding within these limitations, optimizing for the number of qubits. And it goes through a couple of steps of that, right? There's some backtracking that occurs, but largely it's a large nodal network map looking at everything you're trying to do, right? If you load in the data, if you have an adder, if you have some other algorithms, it looks at every way to implement each of these steps. Maybe how many resources does it use? Can you reuse any of those qubits or resources intelligently if you're trying to optimize for that parameter? and then it kind of goes and bounces back a little bit back and forth to get you an efficient solution. But all that's hard coded in because we want to know why it's making the decisions it's making, and we don't want to guess out, why did it give us the solution? And we want to always be able to improve that system and make sure that we're always putting in better and better ways to get you your solution and faster ways to get your solution. Because right now we can make 100 qubit circuits, 200 qubit circuits in no time. But if you try and do 1,000 qubits, it's going to take you a hot minute because we haven't really optimized for 1,000, 10,000 qubits yet, because no one's really programming that in the first place right now. I'd love to do a PR piece. If anybody's doing 1,000 qubits, let me know. We can definitely set you up with that. But no one's doing that. But we want to make sure we do return results to you in an efficient amount of time. No one wants to wait 2 minutes to get that code back that you saw. You want to get that result back to you snippily, and we want to make sure that we're always getting that in. And hard coding all that decision making in also means that our developers can add in new algorithm implementations when new papers get published, because scientists are doing great work coming out with new ways to implement existing algorithms. Right. And like an easy example of that is, right, if you're trying to do addition, there's a couple of ways to even do addition in quantum. You can do what's called like a quantum Fourier transform adder, and you can do what's called a ripple carry adder. And which one is better for what hardware? Which one's better for what circuit connectivity map? If qubits are attached to each other in certain ways, we want to make sure that the system can choose the right implementation of these algorithms for you, and without you having to know every single implementation option available and, the trade-offs of them.
Wow. And that's great. So, and curious about as far as just Classiq and, the challenges that you might have faced like in the early stages of developing this stuff. Is there anything in particular, or is there still a current like challenge that's faced in the industry itself, as far as in the quantum realm that you guys are battling, and just a little bit more background as far as on like the company and at least challenges early on and how you guys were able to overcome them, if there's any that you have.
Yeah. I feel like I watched a couple movies about somebody battling in the quantum realm. So,
I think I put out a blog a while back somewhere just talking about like the future and then of quantum, and I think I just put out some movie titles that I thought were interesting. What's the future of quantum technology, and is it going to be and AI as a replacing technology, or as
we've got someone joining us.
Helps out. Perminder, how's it going?
Sorry, I was stuck in unavoidable emergency.
No worries. Welcome.
All right.
Glad you could make
Welcome.
it.
Yeah.
We were talking about battling in the quantum realm. So.
Oh yeah, I do love quantum movies that either use quantum poorly or just use quantum as a fun catchphrase. It's fun stuff. I love it. I treat it like anytime I watch a time travel movie, I just can't help. I'm like, no, I don't think that's how that would work. No. Or I do love physics, terrible physics in movies. I think one of my favorite ones I saw recently, I shouted out, I was watching Sharknado, and somebody, the shark's in the tornado, and someone has a shotgun, shoots one of the sharks, and it just falls out of the tornado. Like, that's not how that would work. It would stay in the tornado and just be dead. It doesn't just fall out because you shot it. That's not physics.
My son is very analytical like that, so I can't watch those types of movies with him because he'll be like, "That doesn't happen in real life, Dad." I'm like, "I know," but like movies like that one, he was doing it like every 2 minutes. I'm like, "You just have to suspend all belief, buddy. Just we're in imagination land right now."
You just got to give up, right? It's just for fun.
Oh man.
Oh no, it's good stuff. But yeah, hopefully I answered your question, who was asking on the stream here on the chat, some examples and kind of what we do and how that's different than maybe some other stuff you've been looking at.
Yeah, so that was not my yogurt. If that did not answer your question and you have follow-up questions, please feel free to let us know and we'll try to get there.
Totally.
But anyway, everybody, welcome. Perminder from AWS has joined us. So he is our quantum expert. So we're happy to have him on. And yeah, if there's any more in-depth questions, I'm sure Perminder would love to take some. And how you doing, Perminder?
Good. Thanks for doing this, starting this. Was saying I was stuck in emergency, but yes, I'm not expert, but I'm a student. I can say more. Erik is the expert.
Perminder, he's being bashful now. I love whenever you're on stage with me at any of these conferences. I think the last one we did was an autonomous vehicles conference we did together, and that was cool, right? Just trying to get the word of quantum out. And that you were talking about this actually, asking the question about some of the challenges that we faced in quantum or Classiq and how we've overcome them. One is just getting the word out about quantum and where we are. A lot of people, I think just generally, a lot of people hear the word physics and they put their hands up and go, not it. And they get worried, right? So when they hear quantum computing, they think it's like a science project or kind of too sci-fi or out there. It's something that's never going to really see the light of day. And one thing that I've seen that really helped overcome that recently, even when Perminder and I were at this autonomous vehicles conference, we showed some work that one of our joint clients did using Classiq as a backend for it, and they made a GUI application with the platform. And to be able to show a GUI application that is running on quantum hardware on the back end, that made people go, oh, I didn't know we were that far in quantum. that triggered something that made it, applicable.
Yeah, so you're speaking my language when you start talking about autonomous vehicles. Actually, my background before I came to AWS was in automotive industry. So as a technician. And so autonomous vehicles are really fascinating and interesting to me. So how are you guys able to utilize quantum in that space? Do you have any examples? You don't need to go into anything specific, and there might be some things that you can't share. That's cool, but
yeah. I think we can share that. Erik, if you have, do you have that?
Yeah. I think I have it up. I was modifying it actually a little bit before. I was taking that slide deck and trying to make it kind of a universal industry slide deck instead of just autonomous vehicles. But where do we got here? Yeah, I mean, largely right there. There's a couple of things. Let me make this big so we're not seeing all the different stuff here.
Yeah.
And we don't need to make this an autonomous vehicle show. I can easily get with you after this, and we can talk about this.
We can talk about the use case, right? Meanwhile, Erik will bring that slide. I think the whole thing started because Classiq software development platform is sort of like, to design the complex matrix kind of a circuit on a steroid, sort of, right? Like, means you can still design it through paper and pencil, and then you can use programming language like Qiskit or the Bracket SDK to lay out the circuit. But things become very complex. You cannot comprehend the industry or the industrial use case sort of setting with that setting, right? So that is where Classiq platforms shine. But then people who comes from the industry, right? They know more about, or they appreciate more about what business problem you have and what kind of challenges you can solve in line of business application. So when you consider automotive, inside automotive, you have this line of business, autonomous vehicle, right? And then there is another partner like who's everyone knows, comes from the global system integrator Infosys. So they use Classiq platform to solve the autonomous vehicle use case. So in that, if you're familiar with the traveling salesman problem, it is a very generalization sort of problem, right? And then there are various extension of that, and one of that is like how you plan the route for a vehicle if that vehicle has to go from point A to B to C to D, and this point A, B, C, nothing but a city in a sort of like in a city, you will have a different location, and the setting can be like there is a truck out for delivery, which is going to stock up the kiosk with the the various food items, and the driver has to go around that several location in a city. Then how do we plan his route so that there is a minimum cost, and the cost can be $1 or the distance or less time taken at all, right? And then there are classical way to solve this, but then can quantum help this? So this is where, like, one of our system integrator is saying, like, Infosys developed this industry solution, right? And the solution to the industry problem. And what you're seeing right now on the screen is what Erik is showing. Like, you can pick up like those kiosks or the ATM, not ATM, the machines where you stock the food, and then you can lay that out on a map, and then finally, you can create a optimized way of covering that locations, right? And then if you think like this is a big problem, like our Amazon's last mile package delivery or FedEx delivering and all. So every dollar you save or every hour you save, it is net gain, right? So you have to deliver the packages in minimum amount of time, like if you see, because customers are waiting for your order, right? They have placed sometimes like a same day order. So you need a very quick solution, very quick way of mathematically calculate this. Now, I'm saying all that at a mathematical level, but there is a formulation called as cubo, right? And then there is a math behind it. But what this solution is showing is like abstract all of that math under the hood and then come up with a GUI, right? And then you can place your kiosk, and then you can plan your route and all. So it's a very elegant solution. We showed this at Autonomous Vehicle Conference in Santa Clara in September, and hopefully we show it again. They are calling us back now again this year, so maybe we will again create some other similar type of a solution. But this driving salesman or vehicle route problem can be also be attached to the autonomous vehicle, right? Robotaxis also have to probably now shuttle is there. It has to pick up the people, and it has to go through a certain route. So you can do that. The UAV, the unmanned air vehicle, going and using this solution as a trajectory, right? Delivering the packages. Like sooner or later, we will have delivery from Amazon by a drone, right? So it all it's all part of that whole problem, right? How do you optimize a route? And there is math behind it, and then you can apply this to various industry use cases. Erik, please feel free to add what I said.
Oh, I'll just add, right? I mean, most every major automotive company has already even publicly announced that they have investigated quantum computing to some way, shape, or form. There's, PR articles you can find on any of these. Ford, Volkswagen. I know. Volkswagen had a cool PR piece talking about how they used and even implemented a quantum algorithm for their paint shops. How to more efficiently switch out the method by which, or the pathing that they're taking for switching out the paint cans on, how to paint the car and certain things like that. Because every time they have to switch out a can, there's time loss, there's material loss. So how to do that more efficiently. They used it kind of as a toy project, and they implemented it, and they're seeing, okay, cool. This is something tangible. We can use this and do this.
Yeah, that's a fascinating thing about the automotive industry, is that it kind of encompasses other little, automotive has supply chain, it's got sales, it's got customer service, right? So, you could find use cases for quantum in all of those areas, I'm sure.
Totally. And they're looking into it. Also, a lot of companies are looking into it for chemistry reasons, for materials development, right? They're trying to come up with better EV batteries, right? So they're trying to figure out, can we come up with some composite materials that can store more charge, more efficiently charge faster, things like this. And they're looking into quantum computing as a ways to investigate, new materials in a way that they wouldn't be able to do in the classical sense.
Of course, sustainability. That's huge.
Yep.
Absolutely.
Yeah. And I think one of my favorite quotes ever is from a famous physicist, Richard Feynman. And I won't quote it exactly because he's known for using some colorful language. But if you want to simulate, nature doesn't behave classically, right? So if you want to simulate nature, you better do it quantum mechanically. And at the end of the day, chemistry, when you get down fine enough to it, it's quantum mechanics. And no computer is going to be able to simulate a quantum mechanical interaction better than a quantum machine.
Yeah.
Wow.
It just takes less resources. I mean, you know, we're on Twitch. A good analogy I like to use is, right, if you're trying to run, you know, a Super Nintendo machine on your computer, it's taking a lot more resources to you know, run that emulator than the Super Nintendo ever did. Right? It takes more resources to try and run a system that's not native to the system you're running on, to do it on not its, you know, kind of constituent hardware. So that's what we're trying to do with chemistry simulations. We're trying to run, you know, we're trying to emulate something on a system that is not what it's used to, is not what it's actually made up of. So it just takes less resources to do quantum simulation on a quantum computer than it does on a classical.
Yeah.
Wow.
So I see one comment.
Yeah, question in the chat.
Yeah. And David, I sent you one link. Now, this link is a AWS blog, which Classiq and AWS joined hands few days back with Citibank. Now, Citi Israel Innovation Center, and then use case there was like how you can optimize the stock portfolio, you know, in a setting of quantum way. And then the question being asked there is similar: can you apply quantum code in the application of intraday trading financial instrument? I think that is what this blog is trying to show. Like you know, but if you think like machine learning regression sort of setting, right, where you will have historical data, and then what you are trying to do is like predict during the day, like you know, around 1 o'clock, what should be the price of the Apple stock based on the historical. A quantum machine learning way, yes, the answer is yes. You can use quantum computer to do that, but as we know, like the size of the qubit and the depth of the circuit which we can mimic today is a little bit lesser than you know, what classical computer or supercomputer can do, right? But what we have proven on paper is like, yes, at certain point there will be a quantum advantage. There will be large qubit size, you know, and then we don't know when, but in fullness of time that will happen. Then of course there will be this regression time series forecasting kind of like problem, which can have a technical advantage in using quantum computer. So what we did in this case, as well as other researchers who are doing in this, who are doing this year or you know, last year, is like whatever qubits you have, whatever maturity of the quantum computers you have, they are trying to solve this as a toy problem, right? They are trying to use lesser stocks, and then they are taking lesser data in terms of like training and all from previous years. But experiments are going on, and people are proving that, right? Means in some cases, the algorithms which are coming up, new way of doing regression or support vector regression, or using neural network, right? Using penny lanes, QML. These problems are solvable, and they are coming up, you know, at least equal or somewhat near benchmark in terms of like the R2 or loss scores, which are the typical scores which are used to measure the loss and then the accuracy in the machine learning world, right? But this blog is nice. If you guys want to follow this blog, this is the actual, you know, tri-party work. So work was done before the POC was done, and then the result of that POC was published in this blog.
Yeah, I like the blog because it goes into a bit of the math too. So if you want to nerd out and kind of see some of the finer workings of what Citibank was trying to do, it's a cool article, right? Because a lot of these, you know, PR pieces you might read, they're very high level. They don't really talk about too much about how they're doing it or what they're doing. So it's a nice piece. And but like Perminder was saying, at a high level, what they're trying to do is get to a good solution for their portfolio optimization in a shorter amount of time, and doing it through some, you know, cool, interesting mechanisms. and trying to get to that quantum utility we were talking about earlier. Right? They're trying to figure out, can we intelligently modify these algorithms or do some cool stuff to it to achieve quantum utility? And right, to answer the question about kind of this financial trading, intraday trading, the short answer is yes. The long answer is it's not going to happen anytime soon that we're going to be doing high frequency trading using a quantum computer, right? Because that's going to require quite a few, quite a lot of quantum resources to back that up, make sure it's done efficiently, well, with minimal to no error whatsoever, right? Because what we don't want is any of these financial crashes because of high frequency trading hiccups.
Well, I couldn't imagine it being profitable just based off the amount of resources that you're using in the first place. I mean, maybe I'm wrong there, but I don't know.
Oh no, people who are backing these like mega supercomputers that are, I don't think they're worried about the cost of getting the solution. They're worried more about making sure that they get the right mix of assets that if they do that right, they're going to far surpass any cost or issue that they're going to incur from the cost of using a supercomputer or the heat in the room or any of that. They're happy to pay the cost of having that quantum machine run and chug as hot or as fast as it needs to. I mean, that's why all these institutes have supercomputers on site or as close as they can to what they're doing. It's really cool stuff what's been done in high frequency trading, but one of the issues that high frequency trading has in general is kind of there's too much data to process. So at some point they need to use kind of heuristics or intelligent guesses to say, if these measures are going up, that means probably all of this is going down. But they're not chugging all the data to actually check if that happens. And if any of those guesses go the wrong way, if that's going up and this is going up in a way that they didn't predict correctly in the heuristics or guesses, that's when you can have these kinds of, micro breaks in your high frequency trading. And, you have these like 2-minute financial crashes that occur just because the intelligent guesses were wrong for a short amount of time there. And they had to kind of stop, put a stopper to the stop market, refresh things and keep it going. But I'm really hoping that quantum computing is going to open the door to all this promise of big data we've seen. Quantum computers do have the promise to be able to chug a lot more data or the same amount of data in a faster amount of time than classical computers can. And man, we have all this processing power, but there's so much data out there. All the imagery that's being taken, all the data that's being collected. I mean, even people with pacemakers or different, medical instruments, there's so much data being collected even on your own health that you'd love to take advantage of to check and make sure you're more healthy, that it cannot possibly be processed. If we can have a system that helps this, enables this, and helps facilitate all the great data collection we've been doing and then use that intelligently, I'm excited for it.
Yeah.
Well, thank you for sharing that blog, and it is in the it's in the stream chat. So anybody that wants to check that out, I would encourage you to take a look at that blog. City and Classiq about the quantum solutions. I've got it on standby to read after this. So thank you.
I'm just messing around with the software a little bit, showing off something else we have. We're trying to put together something that's kind of like a lab view for quantum programming, right? Kind of some pre-made cookie cutter blocks you put together to make larger quantum algorithms. Again, just trying to make it more approachable. I know, scientists, if they're used to making their own experimental setups out there, have used LabVIEW or something like it in the past. We're in Twitch, so if anybody's out there used Blender before to create different lighting effects or things like this, kind of very similar. You attach the different things to each other in this kind of way. And we're trying to just make quantum computing, like I said, approachable. You can do the hard coding of it. You can have these kind of pre-made code blocks. You set your constraints, your state preparation. You put that into your model. You can synthesize it. Right? We're always coming up with just better ways and new ways to make quantum computing approachable to a wide range of audiences, because this is a crazy cool technology, and we want as many people to be able to use and utilize and come up with great solutions from it.
Nice. So this is a new one, Erik, right? The GUI base.
Yeah, this is new. So you're seeing it for the first time here, Perminder.
Yeah. The folks who are more knowledgeable on the step function in AWS slide, right? Like you drop and drag. So this
Yep.
is sort of like equivalent of like drop and drag, design your circuit using the GUI.
Exactly. Yeah. I mean,
it's on a Python, but this is the newest edition. Nice.
We had a talk yesterday, and one of the examples that our developers showed was using this to make Shor's algorithm. And if anybody out there in the quantum computing land has tried to program Shor's algorithm themselves, it is not a trivial thing. But it was really cool, and just how succinctly he was able to put together this, these code blocks in a way that looks almost like you're just reading the paper, right? Because you read these papers, the academic paper has a figure on there that shows, you put these kind of general quantum functions together in this way, and it works. Now we have a tool that you can put them together in that way that looks like that diagram, and it actually completes the function. And otherwise, it would just be tons and tons, thousands of lines of code to do the same exact thing. So it was just really cool to see that example just so succinctly put and able to, like I said, right, take advantage, right? You can read an academic paper and just copy it and mimic it and get those results.
Yeah. Yeah. Good.
I do have a question to because I love the blog as far as well. I'm going to check that out. Like David mentioned after the show. What underlying components as far as are you using? Any AWS specific like resources that you're using? And I guess just tell us a little bit more about like your
totally.
I have to get the secret sauce, but just interested as far.
No worries. Yeah. Like shout out to AWS, right? Our server is run on AWS, right? So we're using AWS resources to power all this stuff you're seeing, right? This browser-based stuff that's on the AWS, cloud, that's powered by that, backed by that, which also means it's easy for us to scale up. If we want to speed up, helping people get to 10,000 qubit, creation, we just got to buy some more horsepower on the AWS systems. So it's scalable in that way for us, and that's why we kind of like the AWS system to be housing all our things on. But as far as using AWS's quantum stuff, right, we're also hooked up to them, right? We can go ahead, Amazon bracket, I'm looking at their simulators here. We can check their hardware out, see what's available. I'm looking at Aria here. It's online, 25 qubits. We can check things out, and you can use their hardware directly from the platform. And again, our users don't have to worry about what's the API call to call, the Aspen M2 machine, and how do I change that? And what's the call if I change it to this other thing? We're trying to make it as easy as possible, just making a drop-down menu. So you can go ahead and explore and then just quickly execute your quantum circuits.
Yeah. Wow. And as far as a customer coming in, as far as like without Classiq, as far as this platform, what's the typical process for them to, obtain this type of environment? Like how are you guys like saving, the plight to get here, So like, what's that experience, that customer experience like?
I mean, like I said, for most people who are wanting to explore this for non-commercial use, right? You want to write an academic paper on it. You're a student, you're learning on this, or a professor trying to create a course on this. It's free. Create an account, use your name, email address, and you're all set up. If you're in industry and you want to use this to explore for business purposes, you buy a license of it, right? Up. Our salespeople will get in contact to you. We'll, sell you licenses of this software, and you're all hooked up. And, we'll do the onboarding thing. We're not going to abandon you in quantum. If there's one place to not abandon somebody, it's in quantum world, right? So we'll help you figure out, what application are you looking at? Is that an application that, makes sense for quantum or not? Some companies need a little bit of that help, right? They know quantum, something they should be looking into. They've read the blogs. They've seen all these papers saying they should investigate quantum. They see that Classiq's a good way to get into it without getting into all the hardware nitty gritty, or being able to they want it because they want to explore multiple hardware types without being locked into any one modality, right? Nobody wants to teach their developers, Q# and OpenChasm and Cirq and they want to learn one language to teach the developers to take advantage of all the hardware. So, in this case, we'll do a couple of workshops with them. We'll talk with them about, what's your industry? What are you looking at this for? Let's identify a good problem that could be a cool skunkworks project to get your feet wet in quantum, right? Let's also make sure it's something that you can compare it to the classical result, because that's what's going to build confidence at the end of the day, right? What have you already done that you have confidence in the classical space? Let's do that same thing in the quantum space, and then you can compare it. You can see it apples to apples. What does this look like at the end of the day? Are you getting similar results? Are they different? Why are they different? It helps you kind of answer these questions and investigate it too. And then we get into, what does the digital transformation roadmap look like? If you're really interested in quantum and want to get this into your pipeline, what's that take? Because it's not as simple to just say, I'm going to start using quantum all of a sudden. You have to build that into your infrastructure. You have to build that into your pipeline, into your software, so that whatever you're using can seamlessly use quantum when the time comes for that.
Gotcha. Wow. Well, thank you for explaining that. Yeah, that's amazing. So, and you mentioned, like, so there would obviously be, code changes, and so it's not something that you can just do a homogeneous, this like transfer of from a classic computation to quantum. Okay. And is that a heavy lift for customers? Is that something that your clients are experiencing as far as getting that POC, as far as like in like a tangible POC that they can try these things on?
It depends on the project they're looking at. Some of them are shorter term, right? Some of them are short lifts, kinds of things that we've done over and over again, right? Some people want to, hey, I saw this really cool academic paper. I want my developers to replicate that. All right, we'll help you out with that. That's a short lift. We'll help you figure out how to get that done. What does that look like for you? And some of them are bigger lifts, right? Some of them are like these projects from Rolls-Royce and things like that. And they really want to look at, long-term, how do we get this from soup to nuts? Where we're looking at these very large algorithms. We know that we're not going to see advantage in the next year for it, but we want to start making sure we understand how to get this going, where this is going, train our developers, make sure they're going and getting this done. And some are kind of scientific projects where they're really trying to hit that quantum utility. They don't want to just learn. They're really aiming for that quantum utility like Citibank. They want to make sure that they're actively working on ways to take advantage of quantum and get it to quantum utility where it's better than the classical and use that. Now, I don't know if that's a heavy lift, but it's not a quick lift, right?
Yeah.
It's a project, right? It's going to take resources and time to investigate this, to trial and error, to try different methodologies, and hopefully hit that quantum utility where you get more advantage out of quantum.
Yeah,
absolutely. Yeah, and for those who are just joining, I just want to it looks like we had an influx of viewers coming in. Welcome. This is our Howdy partner episode. We are with Classiq today. They're giving us a deep dive in their platform and how we can get your team ramped up in utilizing their platform and talking about quantum computing and how it's actually solving tomorrow's problems as well. So it's pretty amazing. And the next thing, I know you name dropped Citibank, and you gave us the details on that, but I'm really curious about the Rolls-Royce. You did just give them as far as an example there. Can you talk to us a little bit more about what they're looking to do and what they have done as far as with your platform?
Yeah. I mean, right. Rolls-Royce was an interesting case because we love clients like that because they knew their stuff getting into quantum, right? We have some clients who are kind of early stage. They're trying to investigate this, right? We have to do some workshops with them and help them along. Rolls-Royce came to the stage knowing their quantum stuff. They've tried other platforms. They've done stuff, and they said, hey, we're coming to you because you have this high-level modeling language. That's exactly the kind of thing we were looking for. We want our developers to spend less time and move faster on this, right? Because you can only move as fast as the infrastructure you're trying to build on top of. So they saw this and said, all right, teach us how to use this stuff. We're going to work together, but we're good. Let's go. So this was cool, right? And computational fluid dynamics, we say fluid, right? Because that's a physics term, though. That can be anything from air, water, gases. It's not just liquids. And they're looking at it for avionics reasons, right? And I'm sure you can think of plenty of reasons why you want to be looking at how air flows around maybe airplane wings, around jet engines, around things like this to make sure that you have proper aerodynamics, that things like this are well suited. And when you start getting into these very large kind of system level simulations, it starts to get cumbersome. It takes a lot of resources to simulate these things. If anybody out there has done kind of used any of these multi-physics simulation tools like COMSOL or things like that, where you're mixing together airflow, water, the rigidness of your material. You have to worry about a frequency mode, right? If the air hits it just right, maybe it starts to vibrate, and you got to worry about that. Adding in kind of these multi-physics simulations that, they interplay together, it's only as good as the data coming in, and each component you have to worry about how finely you're simulating it, right? When you do these simulations, a good example is, right, you have to figure out what your mesh size is, right? Again, everybody who's working in Blender, right? What is the size of the little polygons or triangles you're putting these things in that you're simulating around, right? And you want to give every one of those regions a solution. But if you make it too large, it becomes nonsense, right? You don't just have one wind flow going across the entire thing. It can be really dynamic. It can flow up and down. It can have different intensities at different points. And the more fine-tuned you make that mesh, the more fine-tuned you make your simulation, the more accurate it's going to be, the more real world it's going to be, right? And issues occur when your simulation doesn't match the real world. As close as you can make your simulation to real world, as finely as you can make it, that's when you're going to see, some really cool things. That's when you avoid issues too. And quantum computing is what's going to enable essentially finer simulations of these systems. Because again, it's too much data to chug. It's a lot of information. It's a lot of processing. And quantum computing specifically is really good at solving systems of linear equations. If you got a lot of linear equations, quantum computing mathematically can show it could do it faster than the classical computer. Now, we need to actually make sure the hardware can get there and the whole software stack makes sense so we can actually see that in practical. But if you're looking at that and the math of it, the math shows that a quantum system can do that better than a classical one. That's just true. So that's what they're really excited about and wanting to explore and do, right? They want to get these quantum simulations to the point where they can introduce it, do maybe longer time frame simulations, larger simulations, finer simulations. And when you're dealing with the kind of, sophisticated, avionics that they're doing, right? You want to make sure that stuff's, top notch and you're not missing anything.
Yeah, no, great point. Yeah, you've explained that very well. And yeah, that's quite impressive what you guys have partnered to do.
I'm going to drop a link in the chat here for our survey. If everybody could just take some time, 30 seconds to take our survey, let us know how we're doing on Howdy Partner. If you want to see more of Erik, Perminder, learn more quantum, let us know.
Yeah. I'd be happy to come. Yeah. So next time I hear it's popular to do Twitch streams in the hot tub, right? That's what gets the viewers.
Allegedly. I think I'm pretty confident that if I did a Twitch stream from a hot tub, that would scare the viewers away. But
yeah.
Your mileage, maybe.
Yeah. Let me share very quickly two things, and then I think Erik, I will hand it back to you.
Cool.
So if you, I'm just trying to share my screen.
Or do we need to stop sharing my screen here for that?
I can remove it. So
all right, cool.
Yep. We can add it.
Okay. So you guys are able to see my screen, right?
Wait, not yet.
Now we can.
All right.
Okay, great. So I think most of you guys are familiar with our reInvent. And of course, the second thing, the Bracket, which is our quantum computing service on AWS side, right? So what we did at reInvent 2023 was launch this badge program. Now, if you guys want to know about Bracket, there is a training on Skill Builder, and there is associated sort of like assessment with that. So you pass the 80% of those questions, you get a badge via that, and then of course you can then brag on with your friends, like yes, in and out of on Bracket. So this is a highly recommended tip from me if you want to have like a baseline understanding of what Bracket is. So this is a good badge to acquire. This is very new, like only few hundreds of people in the world have, and you can be the early one there. The other thing which we launched in reInvent was something called as Bracket Direct. If you're familiar with the AWS reserved instances, right? So this is sort of like a premium reservation system. When you are a researcher, right, and then this experiment which you need for benchmarking purposes or any other purposes has to run for 4 hours, right? Then you can use this Bracket Direct to ask for a dedicated time, like 4 hour, and that slot is reserved for you. Now, why that is important? Because quantum computing or quantum processor units are still a scarce resource, right? If like all of these GPUs which were being shown, like they come online and offline at various time, and then everyone in the world are vying for it. Similar to what people are doing on the GPU side with NVIDIA. So it is even more scarce on this side because there are only few of the QPUs available, and then you can actually submit the task, but then there is no guarantee like it will be executed or when it will be executed. But if you know for sure you want to run this for 4 hours and you need to have that compute or from the QPUs, then you need to use this service. I'd highly recommend you when you plan your benchmarking critical application, you use this. Means right now there is a dedicated device called like Forte, which was also released. INQ systems. And apart from the QPU's reserved mechanism, there is you're familiar with this INQ, Rigetti, Quera, like various modality and various companies out there. Sometimes as a researcher, you are stuck on some issues which you are not able to resolve when you need an expert. And to reach to those experts, you probably have to run through various hoops, right? And then there is no easy answer to how to reach to the expert from these companies. So there is a system in place right now. If you're stuck with suppose like Query device, you can ask for a expert advice for your issues, right? So you go here, connect, and then somebody from Quora will be assigned to you, and they will help you navigate some of the issues you are facing and solve that. This is my other slide, but these two things like Bracket Badge program, which is not, which is I guess, which is very close to what we offer on the certification side for machine learning or solution architect. So Bracket Badge is that closest thing which we have. And then of course the direct one, you can use it for for premium reservation system. So you are first in the line, first in the queue to get inside and then get the access to the QPU for your program.
Perminder, does that cost anyone to to take that course as far as for the badge?
The course is completely free. That is the best part. Okay, so this course, let me go back.
Gotta get me my badge.
All right.
Yeah. So this is a free skill builder course there, right? You can take probably 1 hour, 2 hour, and then there is assessments. It costs nothing. And there is a link here which I will post in the chat. There is a nice blog out there where you can actually follow it and then understand what this badge is and all, right? And then you pass the 80%, like 40 or 50 questions, you get a badge. So no cost. The direct program, which I was talking about, it is sort of like a premium reservation, right? So there is a cost associated with that. I don't remember how much, but it is hourly thing. So you pay for it, but then you are guaranteed that you will have the availability to that GPUs, which is very vital if I'm running an experiment, right? And I know that I need to know, like, I have to complete in 4 hours. So, and then I can reserve tomorrow 10 to 2 and then done with my experiment, knowing for sure like this will run. So you submit it, and then it will be done during that time.
Gotcha. It's kind of similar to, I guess, like the spot instance type of thing, where you like reserved instance types, where you can ensure your
Not the
workload.
spot. Yeah, not the spot. The spot is a little bit of bidding, and then you will get it or not get it. But it is more of like a reserve instance. You can,
Right, yeah, reserved. It's in that comparison, so like reserved instances, so your workload is not impacted.
Yeah, you reserve the time basically.
I'm
4 hours.
gonna have to do that for some of the next workshops I go and do.
Absolutely.
I love running on quantum hardware, right? But in a workshop I'm doing for students or for a company, I don't want to, I'm in the workshop, I'm doing it, I'm going to click run, and then it says, okay, queue time, 3 hours.
Yes.
Okay, we'll get our result back in 3 hours. Nobody wants to wait that. No, it'd be cool to reserve it for that time slot and get the results back right in the workshop and show everybody. That's cool.
Yeah, and then it is, as you read this, right? Like you can get 1 hour increment, and then you can cancel up to 48 hours before the reservation. So you're absolutely right. If you are right now, I think maybe you told the audience like you are in APS, right? Like you are presenting.
Yeah, exactly. You're on stage, something I'm gonna be doing. Yeah.
Yeah, and then you want the absolute guaranteed guarantee, like when you are running your live demo, then you can submit the circuit and you can get the result back to show the live demo. Then absolutely go for it.
I'm just thinking about all the commercial and the kind of marketing aspects of that, right? If we have somebody who's going to be presenting to management or something internally at their company, reserve that time slot, right? You don't want the CEO is not going to wait 2 hours for you to get results back. They want to see it working. That's cool. That's really cool.
Yeah, so we're to share 2 things.
Nice.
No, that was great.
I don't know what happened, but welcome back, everyone.
Glad to have you back.
Yeah, very glad.
Oh yeah, so and we were talking about kind of a support. You were talking about Perminder. We also have a Slack channel on our end, right? So if anybody kind of wants to, if anybody starts exploring Classiq and is using our stuff and has questions about the software, how can I improve my code, or I'm not getting it to work right or something, you can go to our Slack and talk to other people who are using the platform, and you can also talk to our developers right there too. So it's a great time to talk to other people entrenched in quantum and doing cool quantum stuff. Yeah. My favorite though is when I see we have some universities using us for homework and for classrooms. Every once in a while I'll see about like 5 of the same question get asked in a Slack channel. And I know I'm like, is homework due tomorrow or later today? So which one is it? Because these are all the same exact question. That's kind of eerily similar. So yeah, it's fun. I love helping students when they're having troubles with their homeworks and stuff. It's just cool to help and see all these things happen. And man, I'm just amazed by how much students are learning these days and how skilled they're getting. Because our last coding competition, one of the winners for one of the challenge problems we had was a group of high school students.
Oh, wow.
And we had no limitation to who could apply. So people in industry were applying, and one of the winners was high school students. I went, oh my God, I was playing video games. I wasn't programming quantum computers. High school. That's crazy. That's awesome. I'm really glad to see.
Yeah, I'm jealous. I'm wicked jealous. I really am. I tell my kids that all the time. Like, you guys are so lucky to have the resources you have. Because, I mean, if I wanted to learn quantum when I was in high school, like, well, how? I mean, it's just amazing how, like, cloud has enabled people to actually get into quantum more, because now you don't need to buy all those servers and them supercomputers and those large expenses. It's just, I mean, and now it's empowered you guys, Classiq, to go and do your thing and share it with everyone. And so it's just really, really awesome to think about how far we've come just since I was in high school, because it was like not even a thing.
Yeah.
I don't want to age myself here, but
yeah.
It's really cool and awesome. Yeah. I'm talking to people at this show about K-12 education. I'm having I've had some high school teachers come up to me and say, hey, would you be willing to give a workshop at our high school? Because this looks like it's approachable. It looks cool. it's a little easier to use and then pick up for some of the students. And we've been thinking about how we might be able to do, maybe a very simple intro to quantum computing.
Yeah,
let's give it a shot. Let's try it out. Let's bring this to high school.
yeah. Since we are talking about K-12 and the free education, right? Like, yes, there is a similar partner like Classiq, Quantum Astra. Means they this very small partner, but they're based out of Plano, Texas. And in a couple of weeks, I just shared a link which David will share. Well, it's very important, like you at a local level combine your effort sometimes with these city local executive, right? And in this case, this company, Quantum Astra, is organizing a free 3-hour session for the students at the University of North Texas on 23rd of March, 9 to 12. If you are based out of Plano, Texas or Dallas, Texas, this is a free, come learn, see from some of the industry expert what they are saying about quantum education, quantum computing, and then get some free help, right? And it's our duty and responsibility too, because it will take whole village. You need high schooler, you need postdocs, and in between, people like Peter, Patrick, and David.
Oh, yeah.
Everyone, because this is not like a sort of like it's not like a sprint, right? It's a marathon. So this will run for years. So you have to build the talent, you have to spread the awareness, and then of course curtail the hype, right? Hype is not good. This whole quantum being used in movies and all, we should not. My personal belief, not AWS, my personal belief, we should not do that. We should be focusing more on the grassroots level, right? Like this is good effort by Quantum Astra, and then Classiq also. I think correct me, Erik. Like if you are student, you have EDU or the affiliation to some of the alumni on the university side. There is a free version of Classiq for the academia.
You got it.
It's whatever you're
saying. Go to platform.classiq.io and sign up.
You can go and sign up, and then you can start running your basic algorithm to start with, play around, right? You don't have to pay a penny on that. It's academia free.
Yeah, and you're talking about talent, right? Every one of these quantum shows I go to talks about the quantum talent shortage, right? There's just not enough people who know how to program these systems. And like I said before, every major automotive company is investigating this. Most major banks are investigating this, right? JP Morgan has a giant firm of people working on quantum computing. They're publishing research papers on this. Like most major large companies are investigating quantum computing in some capacity, but there's not enough people in the field to feed that need that the industry has for it. So if you're interested in quantum computing, it's a great time to get into it. Like students ask me all the time, should I know how to program C++ and things like that. Should I learn quantum computing? I said, yeah, absolutely. Because no other job can ask you for so little experience, honestly, right? If you apply as a computer scientist to a job in programming, they want you to have like 7 years programming C++ and Python and things like this. You can't ask for more than 1 year in programming quantum computing, right? It hasn't been around that long. And if you have that 1 year, you are the expert in the room. You will be leading the team if you have that year of experience. So it's a great time to get into it, right? Now is the foundation. It's being built up. And if you're at that time where you're looking for jobs and you can be that team lead going into it, it's a career for life, right? You're going to be that person who's been in quantum computing since the get-go, who's seen the industry change. And it's a fun industry because I go to these shows all the time. I'm seeing how quickly it advances. It feels like a different industry every 3 months. Things move so quickly. I mean, because it's also a really interesting bleeding edge technology in that we know what's needed next. We've done computing. We know what the path for computing looks like. We just got to do it quantum. So we know what the names of everything is, right? We know, like, okay, if we want a quantum internet, we need to have quantum repeaters. How do we build that? What does that mean? Things like that. So we know even all the jargon for it. We just got to figure out how to build it and do it. And people have done great jobs building quantum, repeaters now and things like that. So we know the roadmap. It's been built out because we've done computing before. We just got to do it quantumly.
Exactly.
Yeah, I definitely feel like it's one of the most exciting, not most, but one of the more exciting, new kind of ventures to kind of expand on. That's kind of where we're going. That's the future. I know.
Yeah.
Gen AI is the talk of the town all the time, which and rightfully so. It's awesome. It's cool, but
Yeah, I'm using
yeah,
it.
like I feel like there was a lot of talk about quantum a little bit more, and then Gen AI kind of came and sucked the wind out of the sails a little bit, but it's still there. I'm still loving it. I think that's where it's really going to be fun to see where it all goes and where it lands.
Yeah, no, I'm
So
glad
many
honestly a little bit of
opportunities.
that wind got knocked out because the some of that wind was hype, right? And I'm
Mhm.
glad less people have been, like I said, I'm glad the term quantum supremacy has been uttered less, because there's always going to be some workaround where you can have a classical computer do something special and beat out the quantum in a very particular certain way, kind of thing. It can always be argued if you say I have quantum supremacy. Quantum utility is something that matters for your business.
Mhm.
That's when it makes dollars and cents to get into it, right? I'm glad that's what's being talked about more, right? So I'm glad that some of the wind got kicked out of it, because it's creating more honest discussion about quantum, where we are and where we're going to be. So it's been cool. I've been really enjoying seeing all that. And I mean, I've really enjoyed kind of all this AI hype too, because quantum has AI applications, right? Quantum can help enable, right? Quantum machine learning. There's different ways you can create quantum neural networks, right? Creating some really cool interconnections in your neural networks that you wouldn't be able to do classically. And like I said, remember the big data chugging of data. Quantum computing can do that. Your AI, your machine learning model is only as good as the data it's trained on. And the more data you have it trained on, the better that algorithm's going to be. But at some point, you have to call it quits. You can't just keep feeding and feeding and feeding. That takes so much time, so much resources. Well, quantum computing can help chug that data and process it a lot more efficiently, and hopefully create even classical machine learning models that are more efficient because they process the data quantumly in the first place.
Yeah, I mean, I think I definitely see how the two can kind of blend. I mean, I feel like, and this is me using a silly analogy because I love them, but I feel like you could have quantum be like the nutrition, right? And then the Gen AI is like the gym, and you're creating like Superman or something, like both of y'all come together, and it's just crazy, awesome things are going to happen.
Yeah.
Absolutely. Yeah, there's ways these technologies can be combined. And at the end of the day, one thing that I've heard from, like, I talk to reporters, because I'm in marketing and technical marketing, and I talk to a lot of people in industry or journalists, people in news, and they want to know about quantum, and they ask me questions. And sometimes they give me these questions that are phrased kind of on the downturn, but they shouldn't be seen that way. Like they ask, well, I've heard from a lot of people, quantum computing will never replace classical computing. You're right. It was never supposed to replace it. It's supposed to enable it, right? It's an enabling technology, and at the end of the day, quantum computing is going to be part of this whole kind of HPC infrastructure, right? These supercomputer infrastructure that you see. Supercomputers are a mix of a lot of different types of processors. They have CPUs, they have GPUs, they have tensor processing units, right? TPUs, and eventually they're going to have QPUs. And in the same way that a supercomputer sends the right kind of data packet to the right processor for what it's trying to do, QPU is going to be a new type of data processing unit on that supercomputer, and it's going to be really efficient for certain types of things and not for others, right?
Yeah.
Same way, you don't chug everything through your GPU. That'd be inefficient. Don't do that, right? It's really good for what it's good at. It's not good at everything. So send the right data to the right packet, and quantum computing is going to be part of that whole ecosystem at the end of the day. So it's never supposed to replace it. It's going to be part of a holistic technology that's going to enable a lot of cool applications in the same way that advancing GPUs have done.
Yeah.
No, it's fun, the discussions we get into with journalists and things like this, and just kind of the framing of all of it. My favorite answer is always, "You're absolutely right," on these things. Shor's algorithm has always been a cool one to talk about, just because a lot of funding got into quantum because of Shor's algorithm and kind of the worry that it brought up, right? It is true, Shor's algorithm will break kind of the standard encryption protocols. Yes, that is what Shor's algorithm will do. It's going to break RSA encryption in a way that nobody thought, everyone thought RSA encryption was super, super secure. It's kind of a serendipity that quantum computers are so efficient at solving that particular type of problem. Well, oops, now what institutions like the National Institute for Standards and Technology, NIST, they're coming up with different protocols that are inefficient for classical and quantum to break. So they're investigating different methods and protocols, and they're doing a great job figuring out what are the new security paradigms and protocols that everybody should be moving over to that is difficult for both computer types to break. They have a booth at APS too. I was talking to them about this. They're doing some great stuff there. And, most people don't really need to worry about, quantum computing, break-in encryption, things like that. Most everyday companies, unless you're like the government or somebody who your data matters for more than 10 years, then you need to start looking into what you should do in the short term. If your data doesn't matter for more than, 3 years, don't worry about it, right? If after 3 years, that data, that piece of paper you have in your hand right now isn't going to really bring any business value, stop worrying about Shor's algorithm. You're good. NIST will tell you to move over to security protocols that are quantum safe, and when they do it, and you're good. So it's right, a little bit of that. Let's break the quantum hype. Let's be honest about who should be worried, who should be aware of these kinds of different things, and what you should be doing about it. And frankly, I always love the positive spin on quantum, quantum and encryption and security. Quantum can do a lot of things to help better encrypt and secure and build IT management infrastructures that are even more optimal. Like we talk about, like, every problem can be an optimization problem. If there's like a new, something that's breaking into your system, a new vulnerability that's detected, you got to figure out what your patch management strategy is for your company. Which systems are vulnerable? How does that chain together? And what do you tell your developers to patch, in that first hour, in that first day? And then you can patch the rest of it. But how does that spider into each other, right? If I patch this, will that secure everything else down chain? And where does that look like? Quantum computing can solve that optimization problem and help you identify what's the most valuable things to patch first and earliest. And this kind of like real-time optimization is difficult for classical computers to do in real time, right? That's like that's why like when these ships get blocked off in like the Suez Canal or in the what's the canal in the South America that
Panama?
The Panama Canal, right? When ships get blocked off in the Panama Canal, companies go ballistic. They have no idea how to get their goods to the right places because everything was shipped through there. And to do real-time re-optimization of how those shipments are getting sent is a nightmare. It's so much data processing. Hopefully, quantum can get us to a place where we can do more real-time optimization of these kinds of infrastructures.
Wow.
Yeah, so I mean, it spiders out the number of applications that can happen from this, and who knows what further applications can happen. It's crazy the ingenuity of people. Like, man, when computers first came out, I don't think anybody could have foreseen the ways we're using classical computing today. It was seen as a banking tool initially. It was seen as something just for maths. Now we have Twitch streams. Right? I would not have seen that at that time. I don't know how anybody could have predicted that.
Right.
It's cool, right? Whenever you have a new enabling technology, the things that people can come up with and just have fun with, it's fun, and I'm excited to see what the industry brings.
Absolutely. And I think I touched upon it earlier, like we're solving tomorrow's problems. So we don't even know where we're at right now. But it's kind of setting us up for, the security components of it. Like you guys are, like you mentioned now, just the just every, holistically, just like, the example that you use for the supply chain, down to fuel. I'm curious how, the airlines are going to use this, like you mentioned, and how they can optimize their flights in real time, or even just, with traffic, probabilities and all those other, like real world things that you can't really predict. So having that the power and the compute to do that is quite amazing. So I'm looking forward. Like you say, every 3 months is a different industry. I'm wondering how it's going to look as far as at Q4. So very amazing.
Yeah, I mean, there's just so much, right, that quantum can help facilitate and do. And this is me, waxing philosophical, right? These are all the things that quantum can bring, just big old asterisk, because the more passionate I get, the more it sounds like hype. So just want to give a big fat warning disclaimer on that one, right? We are where we are. These applications will not be coming in the short term.
Right.
But when you think about, the evolution of technology, we've always defined it around the materials available to us, right? You have the Bronze Age, you have the Iron Age, right? People, if you read some modern papers, things like that, people might consider now like the plastics age, right? And people consider that because if you look at everything in your room and take away everything that has plastics in it, you're gonna have a very empty room. It's surprising the number of things that plastics are integrated into your clothing, right? There's plastics in that, different synthetic materials. And quantum computing is going to enable better materials development. Who knows what new materials can be developed, created, fabricated with better simulation, better technologies, and enable new materials development, building structures we couldn't have come up with, cheaper materials that might be able to be better produced, better transferred, right? Maybe locally sourced materials. I don't know, right? There's a lot of cool applications you can think about and envision, right? And this is getting a little into science fiction and prognosticating, but quantum physics sounds like science fiction in the first place. We're here.
Yeah.
Totally.
Yeah, I just went and created this account on Classiq real quick, super quick and easy. But this is awesome. There's like so many tutorials and just a lot of content that would be so valuable, like to anybody wanting to learn this.
Oh, and bless you for bringing me back to scope here, because I'm supposed to be talking about Classiq. I'm just talking about quantum and having fun and getting hyped about all the cool things about it, because I love this industry and I really think it can bring a lot of good. But actually, I'll share my screen a little bit more and just share some of the some funness about it, right? We talked about, we have a browser-based platform, right? Platform.classiq.io. But once you create your account, you can go ahead and use it in Python also. Just, pip install Classiq. Here I'm just doing some arithmetic. In fact, I'm getting ready for a workshop, because after this, I'm giving a university workshop remotely. And we do a lot of that. So if anybody's interested in kind of workshops for their labs or universities, feel free to hit me up. I do a lot of that in the States, and we have colleagues in Japan, in a bunch of different countries around the world. So feel free, we're in a time zone, I'm sure, that works out for giving a workshop for you. But you could do some cool things in Python. And the advantage of having the Python interface too is it plays well with other Python packages. If you're, used to using certain things or want to graph things in a certain way, you can absolutely kind of extract the data and do all that in Python as well. And it's nifty, right? The things you can do. You keep that same kind of high level language modeling this stuff. You can execute it, analyze it, see all that. And I mean, there's tons of tutorials online too. We have a GitHub. I can show that. Let me go to my GitHub and show you kind of all the Python notebooks you can download. Okay, good thing I'm already logged in. I'm going to go to my starred pages here. All right, so Classiq library. So Classiq library here. And you can see, we can dive into any of these things here. I like to go into tutorials just because it gives you a good sense of kind of a lot of the functionality you can do in the system. And we have comparisons against, Qiskit and some of these that you can look at, graphs and ways you can do benchmarking of hardware, benchmarking of algorithms. You can see how we can do kind of hardware aware circuit generation, right? We have a cool example here of hardware aware multi-control NOT gates on, depending on the hardware you're trying to run it on, or depending on the number of controls you're putting on there, it's going to give you a different quantum circuit, but changing the code is actually minimal. You're not changing the code hardly at all. You're just pointing it at different hardware, and it's going to give you a vastly different circuit, just again, showing the power of the system, that you don't have to be an expert at all the different hardware modalities and how to change your circuit to be optimal for this or optimal for that, it's going to go ahead and intelligently get that for you. So there's some really cool tutorials that you can go ahead and explore out in the system. And we have a lot of examples too, because, you know, my hope, I'm in marketing. If there's one of these, you know, IBM challenges, if you want to use Classiq to solve it and win that competition, feel free. The platform's free to use if you're a student, and go ahead and feel free to win that competition the easy way. But there's a lot of cool things you can do in the platform and explore, whether you're looking at it for skunkworks projects or you're a graduate student, you know, working on some project your professor has you on. I know one thing a lot of students in quantum chemistry are using Classiq for is for Hamiltonian exponentiation. It's kind of doing your Hamiltonian evolution. How does your molecule evolve over time? And one way to do that is through an algorithm called a Suzuki trotter. And it'll generate that whole long line of code for you without you having to do that from scratch. You know, some professors, they want to do some special things on top of that code. But to save you the time of having to write thousands of lines of code, all you have to do is type in the molecule, you know what the intermolecular distance is, and that code just gets written up for you efficiently for the hardware you plan to run on. Oh, graduate students have come to my booth saying, thank you. You have no idea how much time you have saved me. I'm telling my professor it's taking me days. Oh, it's taking me days. I got it done in 1 hour. Oh, no, professor, I'm sorry. I still have to work late tonight in my office. I can't help you with this project. So it's cool. It's a time saver at the end of the day too, right? Just so you don't have to waste so much time coding in all of this stuff. And that doesn't mean you can't do cool scientific stuff on top of it. Absolutely. And I talk a lot about the higher level modeling of what you can do in the system, right? Here's a, Grover's algorithm. You can call it out as a Grover's algorithm. You can build out Grover's algorithm in the platform from its constituent parts, because every algorithm is based off of a subset of smaller algorithms. So you can absolutely do that and call them all out, or build your own novel quantum algorithm that's a subset of, chunked other algorithms in the certain sequences. And you can do everything from that too. If you really want kind of fine-tune control, you can still call out, I need my Hadamard gate right there in the circuit, So you can have a mixture of two. You can do, state preparation, build it however you want within this efficiency. And then I need this kind of exact gate sequence in this step. And then afterwards, you can optimize however you want as well. So there's some really cool things you can do if you want to hone in on your academic paper on a particular part, but you still want the rest to be optimized for hardware and optimized for what you're trying to do and get to without having to recode that every single time you want to tweak a small component of it. It's really cool and nimble in that way. And that's what a lot of researchers are doing as far as academia, looking into this stuff. And I even saw one professor building hypothetical quantum computers, saying if I have a hypothetical native gate set of this, and I have a hypothetical, interconnectivity qubit mapping, how long or how big is this quantum circuit now? They're trying to create hypothetical quantum computers that are efficient for the algorithms that are developed. Wow. That's kind of cool stuff they're looking at, right? They're like, okay, if I'm using Shor's algorithm or QAOA, what's the most efficient hardware that would exist to make that be a fast speed up? Man, it's cool stuff what people are looking into. Wow. Yeah. So I've been talking for a while. If anybody in the Twitch channel has questions, happy to answer any of them, because I'm also noticing we're kind of getting to the end of time. I want to make sure any questions on this, on the business of quantum. Heck, I can talk about the patents of quantum, because that's a fun topic too. Yeah. I used to do be a product manager for intellectual property search stuff, and patenting of quantum is an interesting topic, because it's almost like patenting classical software, so you have to be careful about how you do it. But I bet you there's companies patenting this stuff right now, trying to make sure that other companies can't do the cool quantum stuff that they're inventing.
Yeah. They're an active area of research, right? If you're a researcher, postdoc, you can come up with a proprietary algorithm. And as a proprietary means you publish it, and then of course, if it's so good, the VCs will be after you too.
Oh yeah. I'll just say, if you come up with something real good, don't just publish it first, right? Talk to your every university has an IP department. has an internal team that handles this stuff. I've gotten these emails from them, and I've messed up in the past and probably messed myself up on a patent or two. You call them, even if it's like half an hour before you're going to give that talk at your conference. If you're at APS right now and you have a talk in the next half hour, you call that team and you say, I'm going to do this, and they will make sure that they do what's necessary so that you can still patent it at the end of the day.
Absolutely.
Because as soon as you give that talk, it's public.
Yes.
Wow.
Yeah. Patent, it means file the patent, and then
Yeah.
If you have further aspiration, sometimes like I have come across the partners, right? Because they are our partners now, like 2-member team out of university, professor and a student. They launched their solution, on AWS cloud using Amazon Bracket. But you also need the other ancillary classical computing service for your web and web services and the security and all. So they try to build comprehensive solution, and the easy path is to become AWS registered partner, build your solution, and then we validate your solution, and then it is launched, right? So there is a path to that, and then you can always reach out to me if you are a prospective partner who want to be an AWS partner, or if you are a researcher in a enterprise and then you want to get started, how to start using Bracket, and then even how to start using some of the solution like Classiq solution to fast track your quantum project, right? You have a nice business idea, now you want to just go and start code, and then you want to give this nitty-gritty details of setting up the user IAM policy and all to someone like Classiq as a managed service, as a SaaS solution, right? You just then can go into that SaaS solution, register as a user, and start using the software and start focusing on your real work, which is creating the algorithm, right? Rather than working to get Bracket called as an API and then creating a user and all that. So that heavy lifting someone can do, like Classiq can do for you. So there is like a path. So, in the interest of time, I think what I can say here is like David shared that my contact details. If you want further assistance on partnership or further assistance on software like Classiq to access, you can reach out to Erik, you can reach out to me, or we can help there.
Yeah, I'm sure you've seen already in this. I love talking about quantum, so feel free.
I'm curious to hear your thoughts on this. I was curious, and I knew I would find one, but I was browsing job postings and found a software architect in quantum computing that wants 8+ years of experience in quantum computing.
Okay, fair. Now, good. There's a couple of things to recall in all job applications. It's a wish list. I don't think we have anybody on staff has 8+ years of quantum computing experience just because 8 hasn't existed. There are ways that people, try and say, yes, I do. They've maybe been a graduate student doing quantum for a while. Maybe they're doing quantum hardware beforehand. Maybe they're doing some like, atom stuff or close enough to quantum that it counts still. But yeah, anybody looking at this, if you're going for job applications, if you're going into hiring and you see a job posting that you really like, that you think you're qualified for, but it's asking for some parameters that you don't quite match, every job application is a wish list, right? It is not a hard and fast, if you do not have this, you will not get hired. Apply for it. Go for it, That's I
thought that was funny. Is it possible to have 8+ years experience in quantum?
I actually really doubt that. And you brought that up, and I'm definitely going to be talking to my HR team after this and going, what are you asking for?
Oh no, it's not you. It's
no. I know. No. My team is on our website. I got to go ahead and chat with them and say, that makes no sense. We're losing talent probably if you're asking for this stuff. Because honestly, I talk to a lot of these engineers at these shows, and some are really gregarious, some are a little timid, and I don't want to lose great talent because we're asking for something that's not feasible.
Yeah.
Oh my gosh, that's funny.
All right. Well,
no, man, this is a great lesson in life, though, in general, right? Don't ever feel like you can't apply for a job because you don't meet every single one of the criteria. I don't think I've ever had a job position that I've been hired for that I met all the requirements for.
Yeah, absolutely. Miles of Danger says in the comments, it says they were building the hardware 12 years ago and just getting it working. So maybe it was that person.
Maybe that person, that team of 3 graduate students in that lab can apply. No, it's funny actually. Everybody who's at the early stages of programming quantum hardware and stuff like that and putting that together, they all built their own businesses. It's really cool to see like this one laboratory. Every one of those graduate students now has their own different quantum company they founded. Wow. It's cool the things you get into when you're into experimental quantum physics or experimental physics in general. Sometimes it is the longest slog doing experimental physics because everything is breaking on you and you are superstitious and trying to breathe on the right side of your lab table to make it work. And sometimes you end up making bank and coming out with businesses.
Well, and it's awesome that you say that they all went off and got their own companies because, like, I mean, we have come so far since then, but in the grand scheme of things, I'm sure it's like basically just one foot in the door at this point,
Mm-hmm. Mm-hmm. Yeah. Right. Yeah, like we talked about, my company, we're abstracting away from assembly level language, right? The standard is still assembly level language, still talking to the hardware.
Yeah.
That is punch card programming, right? If you're looking at classical. Wow. Right? We're trying to make things a little more sophisticated and make it easier, and let's get away from the shoe boxes of punch cards. Now I'm dating myself talking about these references, but right. It is kind of foot in the door early stages. We're getting really excited about the applications and there's still long way to go, but I'm really excited to see kind of which industries are going to be the first to really adopt this, get advantage of it, start saying they're making a lot of money off of it. And I think once a company hits like I made $1 billion off of using quantum computing, everyone's going to go, wait, what? I need to do this.
Follow the money.
Exactly. Yeah.
Right.
Yeah, that's what's going to hit the consciousness.
Well, it was definitely a pleasure talking to you guys about all this. A lot of fun. Learned a lot of stuff. I hope everybody that tuned in learned something. And there's so many free resources that we threw in this chat that I hope you all take advantage of and do some research and learning.
Right.
Wonderful. It was fun.
Yeah, everybody out there in Twitch land, please join us next week for our next show, same time, same channel. I believe, Patrick, you're going to be on that show again, right?
Yeah. You guys are going to see more of me next week, so beat me there.
All right.
Cool. Nice.
Awesome.
Okay.
Well, we really appreciate you. As far as Dr. Erik is for telling us all about quantum, as well as Classiq and the way that it takes away the heavy lifting. So I'm definitely looking forward to see what you guys have in the future. And I also thank you, Perminder and David, for being a great co-host. So thank you all. And definitely, guys, don't forget to please let us know how we're doing as far as with the comment. As far as with the survey, so we can always improve and make sure the next episode and show is better than the one before. So thank you all.
Cool. Good evening. Thank you.
All right.
Thanks.
See you, everybody.
See ya.